All right, moving into direct variation, we need to keep in mind that the x is our input and our y is our output. And so we also want to remember to ID our x, y to let us know our x is our independent variable and our y is our dependent variable. Going into the first question here, Aaron works at a gym and earns $6 for every new membership he sells. We're going to complete the table of values below and create a graph to represent the relationship between x, the number of new memberships, and y, the amount Aaron earns. So I'm going to go ahead and label this with x and y to keep me in mind of what I'm doing, ID or xy. Also keep in mind that our y is always going to be money if there's money in the situation to make it a little bit easier. Now, when I go through and I start thinking about how to write this equation, I think of y equals mx plus b. Our b being a one-time amount or starting spot, and in this question, that's not happening. So we're not going to use the b. What we are going to do is 6 represents the memberships sold, so that's going to be our rate. So 6 is our rate in this case, which is our m. So that would be y equals 6x. From there, we're going to fill in our table, and we would input our x values. So that would be 6 times 0 is 0, 6 times 1 is 6, 6 times 2 is 12, and 6 times 5 is 30. Now, I want to know, is this situation above proportional? And so after I am done filling in the table, I'm going to graph those points to help me identify if it's proportional or not. I know and I have learned that after graphing, you can tell it's proportional if it goes through the origin or if it does not go through the origin. So I've now graphed my points, and I'm going to complete my line, although a little curved. Complete my line through, and I see that it does in fact go through the origin, so because of that it does make it proportional, which is going to go in line with that direct variation. Not only is it proportional because it goes to the origin, but because when you use the constant of proportionality, direct variation, when you use that formula y over x, which we say, girl, why can't you get over your x? This is constant. And what I mean by that is I don't use the origin numbers, but I start with the first numbers. That would be y over x is 6 over 1, and it simplifies to 6. Then I go to this next one, and y is 12, x is 2, and that simplifies to 6. The last one is y is 30, x is 5, and again that simplifies down to 6. So because it simplifies each time down to the same thing, we know that it is proportional. With direct variation, it exists when a relationship is proportional. You can also say that the value of y varies directly with x. Direct variation is defined by the equation y equals kx, where the coefficient k is the constant of proportionality. If y equals kx, we can find the value of k by solving, girl, why can't you get over your x? And we can also say, okay, girl, why can't you get over your x? When you're solving for k, this is where literal equations comes in. You draw a line, you divide by x, and that's why you're getting k is equal to y over x. Continuing on, you're going to use Aaron's situation above, which we came to the conclusion was y equals 6x. What is the value of k, and how do you know? Well, k is, girl, why can't you get over your x, which we determined by doing several times. 6 over 1 simplifies to 6, 12 over 2 simplified to 6, so k is equal to 6 because it's constant each time, and that's because it's 6 each time. When we're writing the equation, while I wrote y equals mx plus b, that was a non-proportional relationship, y equals kx is our proportional relationship. So we would plug the 6 into k, and you get y equals 6x. You're going to use the equation to find the amount that Aaron will earn for selling 13 new memberships. So that's the input that we're going to plug into x. So y equals 6x, y equals 6 times 13, so y is equal to 78, and that is money. You're then going to use the equation again, y equals 6x, to find how many new memberships. So we're searching for the x in this case. Aaron sold if he earned $108, which is our y. So I would plug in 108 is equal to 6x, divide by 6, divide by 6, and x is equal to 18. This is where knowing which variable goes with which number is very important. We're then going to find k, the constant of proportionality, in the situation where the value of y varies directly with x. If x is 4 and y is 36, we're going to plug those in. So to find k, the constant of proportionality, it's y over x, which is simply 36 over 4. When you do 36 divided by 4, you get 9, so k is equal to 9. Now to write that equation, it's y equals kx. We're going to plug the 9 into k, and you get y equals 9x. From there, we know that we are searching for x, and we know that y is 144, so y equals 9x. I plug in the 144, and it's equal to 9x. I solve by dividing by 9 on both sides, and x is equal to 16. I'm going to use that same equation of y equals 9x to solve to find the value of y. We're searching for the y when x is 27. So I'm going to plug in the x, so y equals 9 times 27 this time, and y is equal to 243. These are a little bit more simple as they tell you what your x and y is, and we'll move into the point where we have to determine those things ourselves. The value of y varies directly with x. X equals 12, y equals 3. Use those pieces of information to answer A, B, C, and D. So k, the constant of proportionality, is, girl, why can't you get over your x? That would be 3 over 12, and it is okay to have a fraction or a decimal. That simplifies down to 1/4 or 0.25. Now, using that information, because that is what our k is, we're going to write it and do y equals kx and plug the k right on in. Y is equal to 0.25x, and that would be our equation that we use. Now, using that same equation, y equals 0.25x, and I use a decimal this time because I'm plugging it into my calculator. I know that I'm searching for x, and y is 16. So that 16 is equal to 0.25x. I divide by 0.25 on both sides, and x is equal to 64. Again, using the same thing, find the value of y when x is 36 using the equation y equals 0.25x, plugging the x in. We're searching for that y. Y is 0.25 or 2500ths times 36, and then y is equal to 9. Continuing on to some more real-life situations, the value of y varies directly with x. If y is 4 and x is 20, find the value of y when x is 74. So I have to start by finding my k. So step 1, find k. Then its k is y over x. The two that I actually have to start with are here and here, which is 4 over 20. That simplifies to 1/5, and we're going to use it as a decimal, and we're going to use 0.20. Now we're going to plug that into the equation y equals kx, y equals 0.20x, and now we can plug in the 74 right here into our x. So y equals 0.20 times 74, and then y is equal to 14.8. The relationship between x and y is proportional. If y is 25 and x is 2, find the value of x when y is 125. So again, we're going to start with finding k first. So 1 is find k, which is y over x. We have this one and this one, so that would be 25 over 2. And then that simplifies down to 12.5. So k is equal to 12.5. Step 2, right here, which we did over here, and step 2 was plug in. Step 2, we're going to plug into y equals 12.5x. We have y is 125, so 125 is equal to 12.5x. We're going to divide by 12.5 to get x isolated, and x is equal to 10. Now, those two were very basic, and then moving into the next one, you have to be able to identify the x and the y. So the cost of a smoothie at a fruit mixer is proportional, which tells us we're going to be finding that k, to the number of ounces ordered. If 16 ounces of smoothie costs $3.36, find the cost of a 20-ounce smoothie. I said previously that money is always our y, so that's my y, which makes the 16 our x because the ounces. So x is ounces and y is money in this case. So to find k, we're going to do y over x, which is $3.36 over 16. After I simplify that down, I get k is equal to 0.21. That was step 1. Step 2 is now taking y equals kx, which is y equals 0.21x. I'm going to plug in the 20. Again, we said ounces was x, so it's going to be y is equal to 0.21 times 20, and y is equal to $4.20. In the next one, it's done in a table, so I'm going to label my x's and my y's. The distance of marble rolls varies directly with the time in seconds it has been rolling as shown in the table. We're going to find the time in seconds if a marble has rolled 56 centimeters. So to find k, we're going to do y over x, which we're not going to do the zeros, but we do 7 over 2, 10.5 over 3, and 21 over 6. All of those simplify down to 3.5. So my k is equal to 3.5. Now plugging into y equals kx, which is y equals 3.5x, I can see that I'm talking about centimeters, and centimeters was the distance, so I'm plugging 56 into y. That's 3.5x. I draw my line, divide by that 3.5, and I can see that x is equal to 16. Using all that information, we should be able to fill out our true or false statements. I'm going to come over here, and it says the distance a roadrunner travels, y, directly proportional to x the time. So our time traveled is our x. So in the next sentence, it says x for the seconds, and then the distance right here is our y. So I'm going to go ahead and label those to make my life a little bit easier. You're going to use that information to mark each statement. So I would do k is equal to y over x, which is 34 over 4, and that would simplify down to 8.5. If I was to write that in equation, it's y equals 8.5x. So the relationship can be represented by 0.21x. That is a false statement. That should be changed to 0.8 or 8.5. After 6 seconds, the roadrunner would travel 51 meters. Well, that's time, and time is x. So y equals 8.5x. Y is equal to 8.5 times 6, and so y is equal to 51, and that would be a true statement. If a roadrunner traveled 170 meters, and that's going to be my y, the time passed would be 30 seconds, which is x. So let's prove. Y is, you can use the same equation, y is equal to 8.5x. I can plug in either of those numbers. and I'm going to plug in the 30, so y is equal to 8.5 times 30, and then y should equal 170. When I plug that in, I get 255. I need 170, so that would make it a false statement. You could have plugged in the other number as well. If you have any questions, please let me know.